All right, everyone, let's begin the next session, which is about the topic is the quantum advantage, unlocking India's next frontier in finance. And for the same, I would request the moderator, Ms. Reena Dayal, Chief Executive Officer, QETCI, to join on the stage, please. Let's have a huge round of applause. And now I would request the speakers to join on the stage, please. Mr. Suvendu Pati, Chief General Manager, Fintech Department at Reserve Bank of India. Let's have a huge round of applause, everybody. Ms. Shalaka Verma, Head of Customer Engineering at Google. Let's have a huge round of applause for her. And Mr. Vinayak Godse, Chief Executive Officer at Data Security Council of India. I would request Ms. Reena Dayal to kindly begin the session.
Thank you. Good morning, everyone. Since there are a lesser number of people here, I'm assuming that we have a really focused crowd here, people who are really interested in quantum. So that's always good. And before we begin the session, I wanted to talk a little bit about, set the context of why we are discussing this topic today. All of us are very used to working with computers. And when computing started, we had mainframes, which were the size of rooms. And today you have these devices in your hands, which have more computing power than those large mainframes of that time, right? So this is how technology has progressed. Now, because of Moore's law coming to an end, we are actually looking at new generation of computing technologies, and quantum is a very promising technology in that space. Just to give a little bit of sense of what this is that we are talking about, this is a technology that relies on quantum physics. And just yesterday, the Nobel Prize Committee announced that the Nobel Prize for Physics this year went for some developments in quantum computing. So that's a great impetus to this area. It shows how important this area is and the kind of potential that it holds. At a very fundamental level, quantum computing and its associated technologies, whether it's sensors, communications, etc., they promise very different kind of computing capability. It is supposed to be exponential in nature. As we grow, more advanced quantum computers, we will have very different kind of capabilities. We already are seeing some of that. And then the opportunity to solve problems which are not solvable by classical computers. In the financial sector, the opportunities lie in a variety of areas, in terms of creating great opportunities for innovation, and also strategically looking at how finance happens today and see if there are certain changes that could come in, and also the area of quantum security. We'll touch upon all of these topics in our session today. And we have a great panel, a great set of co-panelists with me here. We have Dr. Suvendu Pati, who is representing the regulator, and he is the General Manager and Head of Fintech Department, Reserve Bank of India. So his team is focusing very deeply on quantum, and that's a great opportunity for us today. We also have Ms. Shalaka Verma, who's the Head of Customer Engineering at Google. So the OEM viewpoint, the services viewpoint, and what is a quantum computing company doing. And then we have Mr. Vinayak Godse, who's the CEO of Data Security Council of India. So that's an industry forum which is focusing on a very specific area within quantum. So this is a great panel. I represent Quantum Ecosystems and Technology Council of India. Our mission is to enable and accelerate the quantum ecosystem in India. And we work with all the stakeholders, all of these people, the government, industry, academia, startups, you name it, right? So hopefully we can give you a few interesting insights into what is happening and what is it that the financial sector should be doing. So with that, I'm going to start with my first question. The first question is to you, Shalaka. Today, as we stand, what are the opportunities that you're seeing for the financial sector in the industry, right? For leveraging quantum?
So let's just take maybe a step back and think about where we stand globally. I think the quantum in the financial sector has, in 2024-25, has moved from theoretical discussion to, I would say, a proactive experimentation stage. So that's really a shift that we have seen in last a year and a half. And that shift is on a dual phase. One is really figuring out how to harness the power of quantum into specific use cases in financial sector. And then the second one is how to get this sector ready for what we call as quantum D-Day, which is the security of this services sector, right? I will touch upon the first part on what scenarios and what use cases are we seeing in the industry at this point. Now, like Reena mentioned, like quantum is dependent on two fundamentally different processes in quantum mechanics. One is the superposition, the other one is entanglement. And that gives it a very specific kind of solution space to operate in. The first one is everything that is quantum mechanical in nature, which includes all kind of simulations that involve molecule, atom, bonds, etc. And that opens up a very wide range of industries in healthcare, material sciences, chemical industries, earth sciences, and so on and so forth. The second one is optimization. In optimization, when we are at a technical or a mathematical level, when we are attempting to solve these problems, the scale is exponential, which means you add a variable into what you want to optimize, the number of combinations grow exponentially. And quantum, given its superposition phenomena, is very good at exploring that space simultaneously, essentially, which does not require a exponential computing power. And that's really the core of all the use cases that we will see getting unleashed. The area is optimization. And in financial sector, I have at least seen about 4 kind of scenarios being explored. The first one is portfolio optimization. In portfolio, if you are going to increase your number of assets, or if you are going to create complex constraints, the cost of computing that is exponential, and hence almost all of our classical ways approximate it to an extent. That is a huge opportunity. Globally, we have seen JP Morgan Chase and BBVA doing very active work on this particular problem statement. The second one is the financial modeling and risk analysis. And I think the financial industry traditionally has been tracking matrices like value of risk or a conditional value of risk. The goal there is to increase the accuracy with a lot more realistic financial simulation of the markets. Again, couple of large financial companies that we have seen doing work in this field is Citigroup and BNP Paribas. The third scenario is algorithmic trading, where the time and accuracy both are of critical importance. And I think just last week, HSBC actually publicly announced the result of the experimentation that they did based on the algorithmic work that they have recently published, that they are able to see 34% improvement on the likelihood that the trade will close at a quoted value as compared to what they are able to achieve today, which is a huge gain in terms of how the customers would see a platform for algorithmic trading. The last one is derivative pricing. Again, that's a very key scenario because a lot of that derivative pricing currently is either time off, like there is a lag in the way we respond to the markets, or the amount of complexity that we are weaving into how when we decide the pricing of the derivatives is limited, and it is limited by the computing power. Goldman Sachs is a leading financial house that I know who is doing a lot of deep work there. But those are primarily the areas where the financial industry is active right now.
So I think that's very insightful. And with that, Vinayak, if you could throw some light on, since you're focused on security, so that and beyond, where do you see the opportunities?
Yeah, so I know in last 4 or 5 years, quantum is something crypto will break and security. There's a lot of doomsday scenario that people paint, right? And I know there is certainly something to worry for because there is a term called utility grade quantum computer, UGQC, you talk about, and why UGQC is now becoming increasing reality and may be coming in some years. Because if you look at the modalities of quantum computing, be it superconducting is definitely maturing. Second is now neutral atom is getting good traction, photonic. So quantum computing is getting good kind of attention of the UGKC kind of a thing. And when you talk about UGKC, we also talk about cryptography relevant quantum computer basically. So there is a understanding like once you reach physical qubit 2 million plus, maybe that is the threshold where it will probably break the RSA 2048 encryption basically, right? But there is also logical qubit, which is now people are saying you may not require then too many physical qubit, but logical qubit error correction is improved. And then with that 2000 plus logical qubit could also probably break the cryptography basically, right? So there is definitely one story about how you prepare for this and how you make sure that current financial transaction ecosystem is resilient to these kind of challenges we'll see in coming future. That's so definitely one worry. But there's another possibility which we see in cybersecurity side. Shalaka talked about what it could do financial side, but we believe cybersecurity is a great candidate. There is a concept called as a local optima and global optima. Most of the problem that we solve in the local constraint, because we can't process all of those variables together at one point in time, right, simultaneously. And cybersecurity always struggle with this because something happened in some part of the globe could happen to you. But how quickly you can process all of those variables so that you identify that one thing which will create a problem for you. So this powerful quantum computer can really help you solve very critical problems of cybersecurity. And we believe that we can also harness like financial sector and many other sector, there's a lot of use cases, but we can also harness quantum computer's power to solve some of the critical cybersecurity issues as well. So that's what I would like.
That's great. Now, you know, as typically happens, the industries, the startups, everybody will say there's a lot of opportunity, a lot of innovation. The crux of a sector like financial sector is to talk to the regulator and understand how do you balance innovation and risk? Where do you see the opportunity, Suvendu?
Yeah, first of all, thank you. I know it's going to be a tough session, so most of the people, I don't know how much they are absorbing, so I'll try to keep it in very plain, vanilla, simple language. See, this is any new technology that comes around. There is always, as a regulator, we need to scan the horizon. And we also see, is it going to impact? If so, in what way? So while the risk side is pretty much well documented and it's been talked about, we believe that very little is being discussed with regard to the opportunities. So we are doing a sort of horizon scanning and looking at this, engaging with international organizations and assessing the domestic scenario. As a regulator, we, there are two clear mandates for us. One is the financial stability, and second is the maintaining the trust in the entire digital ecosystem. And two are intertwined in a way. So one way of looking at the whole advent of this technology, is it going to pose a serious risk to the financial system in India? And given that the growth of digital transactions and now banking, financial services is no longer just it's intricately intertwined with technology and services and offerings, communication included. So our lens is that whether this technology is going to create a huge disruption, are we really prepared? Are our organizations, regulated entities, are they sufficiently equipped to handle this? And at the same time, look at the opportunities that they offer. Are we doing enough to harness those potential opportunities and drive efficiency? So clearly, in terms of the risk management side, there are simulations which can get easier. On the payment side, liquidity assessment and those things which require complex computing can get easier. On the risk analytics and fraud detection side, there are various use cases which require massive amount of data crunching, and that would be a when we are moving everything to a real time. So a lot of computing needs would be required to be addressed. And secondly, given our entire the set of transactions, are we really set for meeting those cryptographic standards requirements in terms of security? If there is a massive incident of data breach, security compromise, the entire trust in the digital ecosystem will go down. So the effort is to see that not only the large entities, but smaller entities are also who are using this. These are ready, and just that's the lens that we are looking at. And the proofing the system will take time. It doesn't happen overnight. So somewhere we have to begin. And quantum is last year and this year, it's no longer a distant concept. It's getting more imminent, more close. So that is why we need to prepare. That's why we are looking at this, and that's why this panel discussion here.
Sure. So that's very apt. I think you rightly mentioned that we have to start looking at it, and the state of readiness is important to understand. So when we go and talk to the industry as an ecosystem entity, we hear two voices. One voice is that people who are very gung-ho about quantum, and they're deep into it, right? And yesterday I was attending a World Economic Forum meeting for the utility sector, which is a very new thing, right? And there was somebody from Iran in energy, and they were so gung-ho about what it could bring to the table. So one extreme, you have these people, and then you have people who will say, I want to wait because this is more of a hype right now, and there's a lot of conversation about hype. In your opinion, what is it that the banks can do right now, start doing right now? What is the immediate opportunity? What is real?
No, first of all, they have to, you arrive at a solution to a problem once you recognize the problem.
Right.
So people would tend to sort of, no, it's not something hitting us now. Let's look at it, later, see it as and when it comes. So that lens, we would want them to change. At least start evaluating your own product, services, and processes. How are they really safe now? Will they be safe tomorrow? So this is something they need to do. And unless we have that baseline assessment of the degree of risk that is posed to them, they would not do. They would not be well prepared to address them. Second, we would like them to have, instead of doing a very knee-jerk reaction and looking at this entire threat landscape, we would like them to have some dedicated innovation vertical within each large institution at least, who would sufficiently, divert resources and to look at the opportunities that they can bring. Are they missing out on something? And this is a new area, and with other technologies, and can they derive some benefit over a long term? I know short term there could be investments, there could be costs around it, but they should be, at a board level, at a strategy level, they should be preparing for a 5-year or a 10-year roadmap and start investing, start acting towards this from now on. And that's the philosophy we would like them to change.
Right.
And from a regulatory standpoint, we are already in discussion engagements on various fronts, but we would like a little more agileness and shift.
Sure.
As a collective manner. It's not something that I can decide something on my own, but let's say we come out with some standards, some
Right.
kind of policies, some kind of uniform set of benchmarks which they can look up to, and then start driving compliance towards that. But yes, innovation potential had to be looked at, and there has to be like a partner with regulator, other industry technology players to look at use cases that can be thought of, start POCs, proof of concepts and pilots, and that would definitely give us a good learning and understanding and help us build solutions at scale.
Right. So over to you, Vinayak. I think Suvendu put out very, very clearly in terms of the first steps that need to be taken by the sector itself. Now, since you're focused on security, I wanted to ask, what is the here and now? What is
Yeah.
really current? And then, of course, what,
Yeah, so
what does that
I
mean?
think we had been talking and with NQM, with National Security Council Secretariat, there is a larger national strategies in making, right? And most of the regulators are involved in that discussion. RBI, SEBI, power sector, MSCA is also involved in that. So there we are saying that now most of the country has made some kind of a roadmap for this migration, basically. Right? So you need to define some clear milestone. The time has come for us to just not talk about it, but now probably put a very kind of a specific milestone. So there's 2-3 milestone. I can't talk about it because that's getting probably discussed today only in public forum, and you'll hear it in some time. So there's a milestone 1 which talks about, but largely it talks about making your cryptography more agile. And agility is very important, right? Because one of the important part is, can you quickly change the new algorithm? Which algorithm is a different story altogether. So one is making your system more agile, and there is definitely urgency for that. And this agility is not only to just immediately replace, but it will be also required for the future, because eventually with high power quantum computing, whatever algorithm it will be always at risk, basically. How quickly you can get hold of and change it. And this changing is not easy. Across system, the interdependency, the value management which we have been working, it's very difficult, this actually achieving this crypto agility, basically. That's the first probably milestone. Second milestone is like, how do you actually transition to it, and who transitions it? So is there a priority level that you can think about in your organization at a national level, basically, right? And third part, which is very important, is the full migration will need to happen, basically. So should it happen as a only quantum pure migration or PQC migration, post-quantum cryptography you talk about, basically, or you could have hybrid system also, because there is there is a possibility of this algorithm that, and this is a very big challenge for a country like India. We are in a way accepting nation in terms of algorithm, to some extent, that there is a concern at a national level. All this crypto algorithm which has been notified by NIST, suppose we notify that as a country and suddenly something happened with that. So who takes this risk? So one of the key things that we have been looking at is, what is the legal liability if suppose somebody goes that early and there is something problem happen with that algorithm, basically. So there's a lot of problem with that, basically. And that's why I think a country like India, there are a lot of challenges and there is a lot of national security angle involved in that, and that's why national security plus NQM is working on this, and one clarity will emerge. And most of the regulators are looking at, once that clarity national will happen, then every regulators can then create some kind of a guidance, obligations and mandates as well, basically. So we see this happening, but I think another 3-4 weeks you'll get exact guideline for most of the ecosystem, plus the regulators as well, so which can be used to create exact plan for now and for the future. This is one important as of now.
Thanks, and I think there are plenty of startup companies in India which are focusing on post-quantum cryptography as well as
And in
other
fact,
solutions.
I'll tell you, we are trying to do that estimate. 10,000 crore, tens of thousands of crore basically will be required for this migration.
Right.
Tremendous opportunity for somebody which is working in this
Absolutely.
area.
Yeah, great. And so, since you already talked about the here and now in the, in terms of the companies, the financial sector companies who are actually taking up projects already, let's flip the question and say, what are the barriers to adoption that you are seeing from an industry viewpoint?
So I think, in a way, even that is also a factor on why some of these companies are taking the bait now, right? Now, I think in the quantum world, the actions that we should take on security and the need to do it now is well established. This is a sector which has longevity of data, and so it is very open to harvest now and decrypt later kind of attacks, which means even if the threat is not real, you'll have to protect the data, which will eventually be sort of stand the truth of the time when the data is there. So I think the push to act now on security is already well established. It's just about the personal motivation of the organizations where we lack right now, right? The quantum computing side is, I think, a different ballgame. We don't really have a machine that will put some of these use cases in production now. So the pivot is really, do I understand the existential risk of this becoming a reality? And am I poised to take the competitive advantage that this technology will offer? And I think that's an answer that needs to be addressed at a leadership level for every organization which is in this sector. It's not like quantum computer is available and somebody is selling it to you, which means you will have a solution to take to the market. That barrier is very high. So there is a lot of work that has to happen on creating the algorithms that are meaningful for the organizations. Right now we are seeing a trend where a lot of these organizations will create the algorithms which are protected, which means that they will operate as IPs within those organizations. So I think the people who have an early advantage of investing into the solutions that will harness the power will be the disruptors in the sector. And so it's a matter of whether you want to be disrupted or be the disruptor, and hence what kind of pole position you will take.
Right.
But also at the India level, I think there is an understanding that this is a very strategic mission, right? Because we have seen the National Quantum Mission operating almost like the way the space mission or the atomic mission for India operates. So I think the conversation on whether we really want to take the bet is also in a way established for us. We want to take the bet. What I feel is that and I think that conversation we had in the Karnataka Quantum Conference also, that our spending on research and our ability to take the early bet is very minimal in India. Like we are about 0.6% of our GDP we spend on R&D and the net new innovations, versus some of the countries who are like US and China, that proportion is 3%, 4% of the GDPs that are way larger than us. So in a way, we will have to take that disproportionate bet now if we want to catch. Otherwise, we will again be in the same boat as the way we missed the semiconductor or the AI.
So I think I take a cue from what you just talked about in terms of the proprietary solutions, and I think the solutions become even more proprietary because today the solutions at the software level have to tightly integrate with the hardware, and the solution changes as you change the hardware. So it is very important and I'm seeing that a lot, that people are, let's say, financial sector, even life sciences sector, companies are actually working with the computing firms, and the joint teams are doing applied research and actually coming up with a solution which will give
most
them
of the
competitive
solutions are
advantage.
IPs.
Yeah,
they're protected.
IP.
Yeah,
Yes,
they're
protected.
they're
Absolutely.
protected.
So that's where the opportunity is. It's the time to get into innovation. Since we are talking about barriers, where do you see the barriers, Suvendu, coming in?
Yeah, basically, what we see, and as you know, it's a very resource-intensive application, and a lot of investments need to go there to experiment, create R&D centers which can run such POCs or pilots. So therefore that is something, and there we feel that some support as a public good initiative by the government authorities, even as a financial sector, we can think about contributing, creating those labs or making those infra available for people to experiment. That's a cost. Second barrier I see is the integration with the legacy systems. And while there is a need that the banking operations or financial services operations can continue as it is, and they would also are getting evolved, but the core systems like core banking system and other things and data integrations with the newer technologies. So that would be something that would be a challenge, and it's friction, but it has to be overcome over a period of time. A third dimension would definitely on the skill set or talent, very, very limited talent and specialized areas these are. So unless the organizations, yes, allocate resources, getting talent, retaining them and doing all this would be very, very, it's one of the areas, and that also fragments, like very large institutions may be able to support, but what about middle or smaller institutions? Like this, and all these things will flow when there is the right tone from the top within the organization.
Right.
So all this will get addressed in a way when there is a thinking that from a strategy point of view, let's invest for the next 10 years on this. So that thinking has to really, seep in and change. It is changing, people are cognizant, but more of that, logical thinking has to translate into action on the ground a little more.
Right. So the biggest barrier is the strategic intent and establishment of an action plan. And then, of course, like you said, then skill building and getting the right resources and getting some public infrastructure going.
Public infrastructure,
I think that is a very good idea. And as a policy think tank, we would, sort of like.
Yeah, for example, we can think of creating industry and financial institutions collaborate on doing a sandbox or an experiment and things like that.
Yeah.
Take a few use cases and start doing those kind of experiments.
I love that answer because in the last financial sector forum, I actually talked about that, and I love the fact that the regulator is also thinking the same. Yeah, so that's great to hear. Over to you, Vinayak, because again, now what is the biggest obstacle in your case?
I have a little bit different opinion in this, right? So we always see this from a development side, supply side, right? We see research has to happen, government has to invest for research and all these things. And if you look at B2C story in India, it's really interesting, right? It's consumer spend, right? And that's why we have created big fortunes like Flipkart and Zomato and many of these, right? So consumer spends, and that's why there's Zeptos and then Blinkits and all this is coming, right? But somehow our enterprises don't spend on a new technology. There's no market. If there's no market, how would you invest into research, right? So this is a big problem of this country, right? Deep tech B2B market is a problem. If there is a market, people would have invested in quantum way early, basically, right? If there is somebody which is, Shalaka talked about so many different companies which are already experimenting. How many banks in India which has been experimenting with quantum right now? How many power sector or energy sector companies? Nobody, right? And in that discussion also, sometimes I also have this frustration with missions, right? All of them are focused on developer side. Those researchers, startup, tech companies. Very few of them talk about user companies. You tell me in any of this mission, is there any bank or is there any user company? If you don't have this market, those who are buyers of technology, then you will not have that investment. You will not have that kind of R&D investment coming from the tech industry, basically. How do you change that equation? If you don't change this equation, it will remain like this for long. I'm really thankful for RBI. The report name is Free AI. It's telling banks that you need to use AI, basically, right? Otherwise, there was a lot of concern of using AI in banking industry. At least that process started, basically, right? The regulator has to tell you that you should start using AI, basically, right? Which is a little bit, this has to be changed. If that doesn't change, things wouldn't really improve a lot in this country.
Right. I think that's a fair point. Now, one of the things that I have noticed is that when we talk about a completely new technology, at least 3-4 years ago when I started talking about it, it was very useful to correlate it to existing technologies. And then luckily, as we are seeing the developments, we are seeing that quantum doesn't work in isolation. There are a lot of opportunities for technologies to work together, right? So I'll come to you, Shalaka, for a longer question, but back to you, Suvendu, and what do you think, where are the technology combination opportunities that you see?
Yeah, one clear connect is on the AI/ML. Everyone is talking about AI/ML, and this is one area where building of complex solutions in AI/ML using AI/ML models are carrying out simulations and other things. That would require huge computing resource, and so possibly quantum would have a very good alignment with AI/ML as another technology where it can combine well. Other thing, of course, I would leave that for other experts to supplement, but my sense is that also if we can look at blockchain as a technology, as whether quantum can help solve some of the proof of work kind of a scenario, and that would have implications for the financial industry as well, where trade finance and other things can have an application on the blockchain environment.
Right.
So a lot of, some opportunities are really clearly visible, but more needs to be explored.
Sure. So Shalaka, what about your thoughts on the combination of technologies?
I'll just quickly do a double dip on quantum AI. I think this is a symbiotic relationship. At this point, AI will help quantum a lot more than quantum will help AI. And in quantum, there are really three areas where we really need help. One is the error correction, the second one is the tuning of the qubits, and the third one is the calibration part. All of these are classical optimization problems that need to get solved, and I think the current state of art on AI will really help us get that in place so that we are really able to create a good computer. Once that is there, though, there are lot of scenarios in AI and ML where the mathematical complexity is too high, and hence we are burning dollars on electricity to solve this. Some of them are like the sampling in generative AI, maybe trying to find the solutions to the equations in core machine learning, even the sampling, the pattern recognition problems, the vector machine problems, right? So all of them have a quantum solve. The algorithms are there. We don't have machine to solve it. So if that sort of works out, then I think it's going to be a virtuous cycle of AI feeding into quantum and quantum feeding into AI.
Wonderful.
There is also this supercomputing aspect to that. Lot of HPC companies are trying to explore the mix of doing the large-scale computing now on cloud rather than putting this on the traditional data centers, because the experimentation goes up and comes down. So there is a natural affinity to how the scale-up, scale-down happens on cloud, but also trying to push some of that into a hybrid workload on quantum and get specific solutions in.
So since we are running out of time, we have run out of time, I'm going to just I ask you a question. If you were to give one statement on what you want to leave the audience here with, what would that one statement, one advice be?
Stop sitting on the sidelines and act now.
Act now. What about you, Vinayak?
I mean, quantum is a possibility, and we should come in terms with possibility early in the game.
Okay. What about you, Suvendu? You have the last word, so to say.
No, I don't have the last word, but yes, on this forum, but yes, look optimistic, look positive, look for opportunities, and stay prepared for the worst case scenario.
Wonderful. Thank you. Thank you very much to my fellow panelists, and thank you for being a great audience. Is there a Q&A?
One question we can take.
Okay. So anybody has any questions?
Yeah.
Sorry, can you hear me? Yeah. I just kind of trying to frame that question in my mind, but let me just say, I see that the fusion of these technologies, the quantum, the AI, etc., possibly might remain in the initial phase at least, it will remain the game for the very big players. Where do you see, and the question is open to anybody, any of the panelists, where do you see the smaller players stepping in? At what point of time do you think that people like us, or the fintechs or startups basically can create something meaningful?
I'll take that. I think it's wrong to really think that the larger players will have the first port of call. We have seen exact opposite in AI. AI became a consumer technology first and then landing into enterprises and then landing into government. So we have already have a precedent to saying that consumers will sort of consume the technology faster. The second thing is that a lot of experimentation and prototyping work is really a lot about agility and having a change. So smaller startups with a deep tech expertise are actually best equipped at this point to create good prototypes.
Can I add to this? Yeah, quickly. Yeah. So if you don't use it now, there is an age of current paradigm that the startup you are talking about. So there is a lot of quantum resources available for you to use on cloud. If you don't use it now, you don't learn how to use it. So when the big one coming in, you're not able to use that as well, basically. First is use, right? And then look at the opportunities that you can do. So use of these for various different applications is a very important part. And if you're in security, there's a lot of possibility for you.
I think with that, we'll wrap it up, and thank you so much.
Thank you so much for an outstanding and engaging session. Let's have a huge round of applause, everyone. That was amazing.